Right, hello, welcome back to our mini-series on the 239152. We're just discussing the required outcomes for the training, and we're moving on to then interpret how that will be reflected in your assessments. We are now going to discuss outcome 3. Now, outcome 3 is just about inspections, so we're not going to talk about any specific tests in this video. That'll be in the next one. The outcome is to understand the requirements for the inspection of the electrical installation. Now remember, in the 239152, this will cover the inspection requirements for a initial verification and the inspection requirements for a periodic inspection or an electrical installation condition report. But there are differences between the two, with both the inspections that you make, the attitude you take to those inspections, and the way that you report them. So we need to just highlight a couple of those. Alrighty. Actually, before I go on, there we go. It's a larger chunk compared to the last outcome. There's going to be 11 questions in this area, and that's not too bad. Not too bad. We'll see. All right. So the first outcome the first part of outcome 3 is the learner can identify the items to be inspected during inspection in accordance with the schedule of inspections. Now, if you were to refer to guidance notes 3, you can see the initial verification inspection guidance in 2.5.3, and it's a blown up list, and it's very useful. It's very useful information. It's got your general inspection checklist. It then goes on to some specifics: lighting control, switch gear, socket outlets, fuse connection units, cooker control units, and that's quite useful because quite often they may pick up in the assessment. They may say you're going to carry out the inspection for a cooker control panel, and it'll ask you to explain 5 inspections. If you could pick up one of the ones that is unique to that then that'll be very good. That'll be a guaranteed mark. But if you just stick with general, then you're losing accuracy. And if you go with things like check connections and is it tight or check erection, then you're not really giving a specific understanding of the inspections on the question. So the obvious thing is you need to understand what inspections to carry out, and your general knowledge on all electrical systems is important here. You may be asked a question on your inspection for a steel conduit system. If you've never installed a steel conduit system, it's worth developing a bit more understanding on the system so you can understand what inspections you'll need to make, because you can't really be certified as being competent to inspect steel conduit if you've never really worked with it. So think about any other development you may need, theoretically and practically as well, at the same time here. 3.9.1 is the condition report inspection. It's more of a verification and a checking of the condition. It's not really a check, so to speak. We'll see this in a second. It's important to say that guidance in Guidance Notes 3 is good detailed guidance, but the question does say the schedule of inspections, so it will relate more to the documented inspections. I'm going to compare them both towards the end of this video, but a quick preview of the electrical installation condition report is here. So I'll be trying to get as much understanding on all of this as possible, and this is where you really just need to talk to your trainer, get them to explain any of this further. If any parts of these inspections are completely foreign to you, then you need to seek further information on them. You can't just put an NA because you don't know what they are. You must understand what all of this information represents. We're going to cover the 2 schedules towards the end of the video. I just said that, right? The next thing, the learner can explain how the items on the schedule of inspections would be verified or classified. Again, the electrical installation certificate is your initial verification. It's your way of documenting that the work has been carried out as designed, as constructed, and inspected thoroughly. So all that report or that inspection schedule should contain is either confirmation or not applicable. We don't put limitations on them, we don't put codes on them, we don't put crosses on them, because what you're saying there is your work is crap. We don't commission crap work. If you are doing an inspection and you have an issue, a non-compliance, a cross, that's where you stop reporting and you stop the process and you go back and you repair, or you contact the installer to fix it. From the condition report angle, though, yeah, we are going to an existing system, so it may be confirmed with a tick, it may be that it's not applicable. It may be that there's a limitation because we have been unable to access, or there's been limit on time. We don't do limitations on new installations because the inspection should be carried out at a time suitable. We shouldn't cover up cables, plaster over them, and then come back and go, oh crap, I can't inspect it anymore. We should have inspected it before it was inaccessible. So there's no excuse for putting it. There's no reason we should put limitations on those. The not verified, there are a couple of examples in Guidance Notes 3. If you look in periodic inspection where it says the types of tests, for example, this is something that the NIC didn't like when I mentioned it to them at a conference, but they have taken not verified off of their certificates because they want to. But if you go to the section on testing in part 3, which is Guidance Notes 3, page 83, it tells you with the tests to be made, for example, ring circuit continuity. Where there are records of previous tests, this test may not be necessary unless there may have been changes made to the ring final. So again, it is up to the inspector to determine the state of the existing system, any recent work, any modifications. If it's well maintained, if it's not been touched, the guidance note does say you may not need to do this test, so it may not need to be verified. It's not a limitation, and it's not applicable, it's just not verified. That's why we have the ability to use not verified. If your certificate, like an NIC or whatever, doesn't have that, well, it's just a bit crap really, isn't it? FI, further investigation. If there's a fault found that's not been identified or anything like that, or you need to do more work, then we need to obviously report that and say that there needs to be more work, more time, more access, maybe access equipment. Those do result in an unsatisfactory report, though, so don't use FI for the sake of time or hassle. Use it if it's really needed. And then we have the C1, C2s and C3s, the coding. So we use those on the inspection schedules as well as the actual observations and recommendations. We can put codes on the inspection schedule with the periodic. With the installation certificate, it's only a tick or not applicable. So you need to understand what you can put on your inspection schedules here. 3.3. The learner can describe the appropriate human sensors required for a particular type of inspection. I covered this briefly on the 2392 video. It's on every single testing course, that's why. You've got to recognise the most suitable type of inspection to identify a suitable thing. So if you're looking at conductor sizing, quite often we may see the conductor size and go straight away, oh yeah, that's fine. So that's primarily going to be the sense that we use. Although sometimes with the installation type, it might be that we're not quite sure, and we may then go on to actually touch it. We may just try to get an understanding of a couple of conductors beside each other. So sometimes touch is needed. But it's important to know that touch should always be minimized or always be avoided as much as you can, because using touch for things like torque settings and connections, etc., there's a risk of manipulation of conductors, cables coming out, but there's a risk of shock. So always avoid touch. Sight, sound, smell, understand when you can use them, what kind of inspection defect you can find with them. So what have we got here? Sight, lack of ingress protection, incorrect cable types, absence of barriers, incorrect identification. Sound, arcing, faulty equipment, use of audible equipment, such as your socket indicators and things. Smell for overloading equipment, faulty electronics, ballasts. This isn't exhaustive. There's a lot that you can put in here. And then touch, yeah. Have a look through the inspections. Have a look at what the inspections are. Think about what inspections you can make, and then think about what sense you would use. This should be fairly simple. Alright, 3.4. Describe how to deal with an item that is found unsatisfactory during the inspection process. And the reason it's gone 3.4 to 3.5 is because that's how City and Guilds have done it in their handbook. They've messed up. So if we had a issue that was unsatisfactory on an initial verification, as I touched on a minute ago, this is an initial verification. This is you signing off your work or signing off your company's work. So you can't sign off something that is unsatisfactory. So you stop the work, and then you identify the fault. you remedy the fault, then you retest to verify the fault is now clear, and then you resume. This is why we have a sequence of tests, so that we can actually stop at a point and then not have to go back to the beginning and start again. We can just carry on from that same test that found the problem and push forward. If, however, your repair work introduced new cabling, new parallels, then maybe you want to go back and start some more subsequent tests. You know, a competent person would understand the differences with those. But you always stop, identify, remedy, retest, resume. Okay? With the periodic, though, we have to assess the situation. So we're going to determine the level of risk associated with the item that's been found as being unsatisfactory. If it is a C1 or something that is dangerous, then we should take immediate action to remove this risk. It doesn't mean fix the problem, it means remove the risk. So it could be that you've got an exposed live part and you just have to blank something off or lock off a circuit. You know, you don't have to then suddenly go and source a brand new accessory that matches the damaged product. You have to just make the thing safe and allow the customer to have a safe system and decide on what actions to take. We'll determine if further investigation is required and then report coding it, doing the observations, recommendations with sufficient detail for the customer. So don't go faulty socket, don't go broken cable. Actually explain the problem, explain the cause, and explain the solution. Give the customer something to actually work with, think about, and cost. Okay. 3.6. The learner can understand how the IP classification system is used for electrical equipment. Now this, from your knowledge of the wiring regulations, should be fairly self-explanatory. We know about IP ratings. We have the first value for the solid ingress. We have the second value for the moisture ingress. We have obviously other grades like XXB for the finger barrier with the 2 knuckles, 80mm penetration. We have IP XXD. Have a little reviso on those. IP2X, IP4X are the common ones for protection against barriers and obstacles in 416. But I would say also think about the external influences from special locations. You know, swimming pools will be down to IPX8 or IPX7. You've got things like saunas and stuff. So have a good understanding on how the wiring regulations reflect changes in IP ratings, minimum IP rating for outside lighting, things like that, and then that should be sufficient. That should be sufficient. Okay, let's quickly compare these then. There we go. Alright, on the left here is the schedule of inspections for new work. On the right is the schedule of inspections for domestic. It's the condition report, so it's the periodic one. They both require now us to assess the condition of the supply. Now it's not with the initial verification. You're not certifying it. You're not confirming it to be acceptable. You're having a look at the supply intake, because bear in mind that that property is the supplier's. It's not the consumer, so it's not yours to work on. But you're just having a look at it. If it's hanging off the wall, if there's a problem, then you're the competent person who is there to raise awareness for the customer. So there is a need to report its condition, and that's the case for both periodics and initials. What else do we have with initials? We have to consider the parallel or switched alternative. So you may have a solar photovoltaic system, which will be a parallel supply. That's not a switched alternative. It will be a parallel. Okay, you may have a standby system. Then you have your ADS. So this is where you think about protection against electric shock, how ADS is achieved. We have a TT system, potentially may need electrode, although obviously with the 18th edition we may have to start having electrodes on some TN systems as well. The sizing of your earthing conductor and connections, main protected bonding conductors. All of this should be as designed. So if it is as designed, then this should in theory be confirmed. Okay, but this is only your work that you're certifying this for. How you've achieved basic protection, installation of live parts, double installation, barriers, enclosures, IP rating, etc. That will confirm those. And remember, with this, all we're going to do is a tick or an NA. I'm going to do anything else. Other methods of protection. Additional protection RCDs, not exceeding 30 milliamp. Supplementary bonding. So this is all going to change again with the 18th edition a little bit, but this is what we have right now. Other methods: self, PELV, double installation, or electrical separation for one item of equipment. So these are the common protective measures. If you think of the wiring regulations, chapter 41, you've got general protective measures: ADS, double installation, self and PELV, and electrical separation. This is making sure that you've achieved a method of compliance with at least one of those throughout the system. You've got consumer units, distribution boards, adequacy of working space, presence of link main switch, isolates for every circuit, etc., etc. Have a good read of this. On your course, though, your trainer should give you good time to think it through, good time to understand it. If you have questions, let's say for example you're not sure on what this means, the avoidance of heating effect with ferromagnetic enclosures. So your awareness of the theory of circulating eddy currents, etc., having a heating effect. There's some truth in it, but you need a lot. And if you actually look at another YouTuber, John Ward, he's done a good video that kind of explains this a little bit more detailed. But if you have no idea what it is, ask your tutor about it. Don't just NA it because you don't know what it means. Adequacy of cables, segregation of band 1 and band 2, so ELV and LV circuits. You must understand the difference in the bands, which is the difference in the voltages. So ELV is up to 50 volts AC, 120 volts, ripple free DC. Band 2 is beyond those voltages up to 1000 AC, 1500 volts DC. If you don't know your voltages, then that's going to confuse you as well. And so on. Again, some of this might be not applicable. If you're in domestic, you may not have band 1, band 2. You may not have ferromagnetic. You may not have emergency switches. You don't know. Who knows? But have a good read through those. For the condition report, you notice it's more a case of presence, confirmation. It's more of, are they there? Not, have you done this? Yeah? So this is where some of this may not be applicable because it might be outside of the scope of the install. It might be that there's a limitation to some of this because you've not been able to access these to carry out these inspections. Okay, but there's a lot of familiarity with some of them, and some of them are unique. So have a good read through, and you'll notice here the ability to report on here includes using the C1, C2, C3, FI, okay, NV. We actually can code on the inspection schedule as well with the condition report. My training, we would go for every single inspection and we'd give a scenario that to actually practice on that would that would fail some and pass others, just to make sure that you've all got an understanding on the difference between the two schedules. The problem with doing the 239152 is your assessment is kind of going to be merged a little bit. The practical is broken into an initial verification bit and a periodic bit, but the actual assessment is not. From my current observation of these assessments, what they do is they try not to question something that is leading over to one or leading over to the other. They kind of try to make the questions more generalized, so it shouldn't be a problem. But do make sure that you're happy with these schedules. As I say, there's plenty of resources online. I think the NIC have stuff on this as well, but do take your time to understand all of these inspection requirements. And if you have any questions, then let me know, but I will, on my training, provide lots more detail on this, but I'll try to help you as much as I can with this YouTube stuff on this as well. But to go through this in detail would take hours. We haven't got that time. I'm going to assume that's enough. Have a good read of Guidance Notes 3 as well. Understand the differences. Yeah, we'll leave it there. I don't want to go into too much onto it. But I'm going to start laying out another video now, which is the outcome 4, which is the testing. And then after that, we'll actually get some practicals, which is I'm looking forward to doing that. Gets me off this desk. So that's the inspection outcomes. Take them on board. Understand the schedules as best you can. Understand the census. Understand how to report them, and you'll be fine.